In this problem, we are going to create a function that determines if a given year is a leap year. And to do this, we are going to be using if statements. We're going to create a flowchart first in order to solve the problem more in the abstract, and then we're going to use that flowchart in order to build our program in Matlab. So first, we're going to have to look at what's the definition of a leap year. How do we know if a year is a leap year? These are the rules we're going to follow. That a leap year is determined by a year that is divisible by 4. However, it's a year that is not divisible by 100, except when the year is divisible by 400. So this would be saying that like the year 2000 is a leap year because it is divisible by 4, it is divisible by 400, but the year 1900 or the year 2100 would not be a leap year. It is divisible by 4, however, it's also divisible by 100, which would exclude it, but 1900 and 2100 are not divisible by 400. And then years like 2020, 2024, etc., those are leap years. They're divisible by 4, but they are not divisible by 100, and then it doesn't matter if they're divisible by 400 or not. All right, so using this rule, let's see conceptually how can we build our function. So it says we're going to be given a year. So that's where we're going to start, is with the is called year. All right, so we're going to take this and we have to evaluate it to see what it follows. So first, the order doesn't particularly matter, but we're going to take year and we're going to make a first decision with it. So take year, we'll go to this decision block, so this diamond shape, and we're going to ask, is year divisible by 4? Right, so it's a little cramped in here, but that's okay. So is the year divisible by 4? So if that's true, we're going to take one branch, and if it's false, we're going to take another branch. So looking at this, looking at our rules, if it's not divisible by 4, then certainly it's not going to be a leap year. So this false is going to take us to a return of 0. So if we look at what we want the function to return a 1 if it's true, and a 0 if it is false. So 1 if it's a leap year, 0 if it's not a leap year. So when this is false, we're going to say that automatically the year is not a leap year. So that'll take us down here to, I'll call the result here leap will be 0. If it's not divisible by 4, it is not a leap year. Now, if it's true that it's divisible by 4, now we come along this branch. However, we have to look at this second test, this second condition. It cannot be divisible by 100. Well, unless it is divisible by 400. So we have to now look at the divisibility of year by 100 or 400. So the order kind of doesn't matter here, and we'll see how that plays out. Just because it's listed in the order, I'm going to look at, is it not divisible by 100, or I'm going to test year divise by 100. So if that is false, if it is not divisible by 100 but is divisible by 400, then it is a leap year. So leap will be 1. And I need to change this block because this is an output. All right, and then we can keep going here. If the year is divisible by 100, that doesn't mean it is necessarily not a leap year, because remember, it could be divisible by 100 and 400, like the year 2000, and then it is a leap year. So if the year is divisible by 100, we have to actually do one more test here on year. So year divisible by 400. Now, the flowchart we're making and the way that this is set up is not necessarily the most elegant way to do it, is not necessarily the most efficient way to do it. But as we're planning this out, we want something that works first, and then we can think about how could we make this more efficient. And we'll get to that as you get more experience in building these logical statements, building our programs. But for something simple like this, this is going to be okay. So as we go down here, we have determined in this first block, it is divisible by 4, it is divisible by 100. So now we want to test, is it divisible by 400? So if that's false, that's divisible by 100 but not 400, well then leap is 0. It is not a leap year. But if it turns out it's divisible by both 100 and 400, and this is true, then leap is 1. All right, so again, let's test this before we start to code it, just thinking about a year. So let's look at like 2020. So as we come up top on year 2020, we go to the first statement. Is 2020 divisible by 4? That is true. It is divisible by 4, so we come down here. Is 2020 divisible by 100? No, it is not. So that's false. We come along this branch. Therefore, it is a leap year. If we think about 2000, 2000 is divisible by 4. It is also divisible by 100, but it is also divisible by 400, so it was a leap year. 1900, if that's our input, divisible by 4, also divisible by 100, not divisible by 400 though, not a leap year. And then something like 2021, that comes in. Is it divisible by 4? No, false. So right away we can say it is not a leap year. So this basic structure is going to get us, at least in abstract, the function that we want to code. So we're going to take this and now we're going to implement it in code. You'll notice that right now I just have kind of ideas of divisibility. We'll have to implement that in the code, and that's where it gets a little bit tricky, but at least we know the general structure that we want our code to have before we start actually typing anything out and then testing it. And at least in this flowchart form, we've tested a couple of values that we know that the answer should be, and it looks like the logic of how this is put together does work correctly. So let's go into Matlab and implement in code the flowchart that we just made. Okay, so let's start building our function. So this is meant to be a function, so the output here is, at least in the flowchart, I called it leap. And I'm going to call this, well, for the purposes of this demonstration, I've already named it, as we can see in the file name. So this has to be called the same thing. So compsci 200 L03 leap. And it was going to take one input, year. And we were told that year is always going to be a scalar value, and it's always going to be an integer. So we can program this going forward with that in mind. All right, make sure everything's spelled correctly. Okay, so now the skeleton is built. And I'll just put the return at the end, or you can use end there. And now I have to start to fill in what we have. So let's look at the flowchart and see what's happening. So we started at the top where we have our input, which is year. So that happens automatically. That is when we called our function. So year is given to our function. So what we want to see is year divisible by 4? So how can we see if a number is divisible by another number? Commonly, we are going to use the mod. So mod. So basically, what does mod do? It's going to return the remainder after we do a division problem. So for example, if I take 2000, if 2000 was the year, so let's just test that out. So if year is 2000, if I do the mod year comma 4, what I'm doing is I'm taking year 2000 for this example, dividing it by 4, and it gives me the remainder, which is 0. But if I take a year like 2021, it gives me 1. So when I divide it by 4, I'm left with the remainder of 1. And if I mod 2022, I get a remainder of 2. So basically how we can use mod is if the mod is 0, that means that a number is divided evenly by that second number. So 2000 is evenly divided by 4. That's true because it returns a 0. So anytime a number is divisible, the mod of those two numbers will return 0. So if we look at this first statement we come to, is our year divisible by 4? So we can look at mod year, comma, 4. So again, this is going to be a 0 when it is divisible, and it is going to be not a 0 otherwise. So looking at how we made our flowchart, if this is false, then we want leap to be equal to 0. So I'm going to put in the if statement because we're at this decision block here. So if the mod of this, we want it to be, so really if this is false, then we want it to return, or if the mod is, if this returns 0, that actually means it's true. So it's a little bit confusing here, but we can use this a couple different ways. So I'll put this here. So if the mod is equal to 0, let's see how this works just in test here. So 2024, is that equal to 0? Yes. So when it's equal to 0, that means it is divisible. Then we're going to go further in our structure. But if this is false, I should put the else here right now. So this is taking that right branch, then leap is 0. And really, we're done. All right, so I still have to fill in the stuff here because we're going to have kind of an if inside an if inside an if. All right, so I've taken care of the right branch, leap is equal to 0. On the left branch, if this statement is true, we actually go to another statement. Is the year divisible by 100? So inside this if, I have the next statement. So mod year 100. All right, so this takes me to that next decision block. So is the year divisible by 100? So again, this statement will evaluate to 1 or true. If the year is evenly divided by 100, it will evaluate to something else otherwise. So again, let's look at 2020. We are going to get, let's get rid of this for now. So if we just do the mod, it's equal to 20 because 2020 divided by 100 has a remainder of 20. So that returns a 0. It's false. 2020 is not divisible by 100. But again, if we take a year like 2000, that returns a true statement. So if the mod of this is equal to 0, that means that that year is divisible by 100. Looking at our flowchart, we actually will go to yet another if statement. So we'll put that in later. I'll just put stars here to remind us that stuff goes in there. Else, so this means that the year was not divisible by 100. Well, then according to our flowchart, leap is equal to 1, and we're done with that branch. And I'll leave some extra spaces in here for now. And then we need to end this block. So this here, this if block is that second decision, that second diamond that we came to. Now, when that decision was true, we actually go to a third decision block. So in here, we're going to have yet another if statement. If the mod of our year and 400 is 0, so is the year divisible by 400? When that is true, then leap is 1. Otherwise, if that's false, then leap is 0. And then we have to end that block there. All right, so let's make sure everything's indented correctly here, and I'll get rid of some spaces at the moment just so it's a little bit cleaner to look at. So I have these nested if blocks, which are not necessarily the most elegant thing to look at here, but let's at least look at this first version of our code that's based on the flow chart that we built. So what did we have to do in the code? Well, we had to look at that if statement, that decision, and turn that into code. We just have it written, is the year divisible by 4? Is it divisible by 100? Is it divisible by 400? In the code, the way we can implement that divisibility or being a factor of a number, mod is a common way to do it. So again, if it's evenly divisible by a number, the mod will be 0. So if it's equal to 0, that means it is divisible. If it's anything other than 0, that means it's not divisible. So let's look at this first version of the function before we look at how can we maybe reduce this down or simplify it a little bit. So I want to test it out here with different years. So let me test the function like we did otherwise. So let's look at 2021. It returned 0. 2021 was not a leap year. 2020 returns a 1. It was a leap year. 2000 returns a 1. It was a leap year. 1900, a 0. It was not a leap year. And let's look at 2100, also a 0. 2100 will not be a leap year because it is divisible by 100, but not by 400. And one more test here. Let's just look at 2019. Again, 0 was not a leap year. All right, the code does work, but we have these nested ifs, which is not the worst thing in the world, but just because in the flowchart we flowed it that way, we drew it that way as kind of an if inside an if inside an if, that doesn't mean we have to stay with that. So this works, it's fine for now for a very simple program, so there's no reason that we have to change anything, but we can kind of condense these ifs down a little bit here. So let's see. So we can actually put these all into a single statement because we can chain together multiple conditions with and. So it has to be true for something to be a leap year. It has to be divisible by 4, and it has to not be divisible by 100 unless it is also divisible by 400. So let's start condensing this and see where we go. All right, so I can put here and mod year 100. All right, so let's see what this has to be. All right, so the mod is equal to 0, so it does have to be divisible by 4, but it cannot be divisible by 100. So let me just do a test in here, kind of one piece at a time to condense this all into a simple statement. So again, let's try 2020. All right, so the first part of this evaluates to a 1. The second part of this is it not divisible, so I'm using this tilde equals 0. This also evaluates to true, so both of these things, it'll be a 1 and 1. 1 and 1 evaluates to 1, which is true. So in this case, we can say leap equals 1. Else, leap equals 0. I'm going to get rid of the rest of this here because it worked, but it's kind of burdensome. Let me actually keep it for the moment. I'll just comment it out. Now, we're not quite done. This has one flaw left in it, but let's just see what happens. Right now, it's only testing, is it divisible by 4, but not divisible by 100. But let's, again, test it with some different years here. So 2020, yes, it evaluates to 1. 2021 does not, so that's good. 1900 was not a leap year, and 2000, it is saying was not a leap year. I have to still put in here the logic for, is it divisible by 400? All right, so let's put that in and see how this works. So when I divide by 400, is it equal to, is it divisible? I'll put a connector in here in a second here, but let's just say our year is 2000 as we test this. So this statement here should evaluate to 1, but this statement has evaluated to 0. So what I can do here is put in or. Again, there's only one way to do it. So let's see what happens here if I string it together with this logic in this much more simple way to do it, although the first way we did it was also correct. Now, let's see what happens. If I have a year like 2000, then this first statement inside the parentheses evaluates to 0, but the second statement is going to evaluate to 1. I have a 0 or 1. That 0 or 1 is going to evaluate to 1. So let's just Make sure that's true, and that is true. And that year was divisible by 4. So I have 1 and 1, which means it is a leap year. So let's test out this 2000 evaluates to true now, whereas 1900 still evaluates to false, and 2100 also still evaluates to false. So I was really able to, a little bit more advanced, put together some of these logical statements into one thing, and I can reduce having lots of lines of code. I can have all these, reduce all these nested if statements into a single statement here by chaining together an and then inside here an or. So both ways of doing this are correct. While you're starting out, while you're learning to program and put together these decisions, these if statements, these nested if statements are okay to use. And as you get more comfortable, as you get more practice with it, then you're going to see where you're going to be able to start reducing some of these statements into something that's a little bit simpler to look at, and it's going to be much easier to modify as you go forward. But either version of this function is accomplishing our goal. They are both adhering to the flowchart that we put together, and as we tested it with different test cases, 2000, 1900, 2020, 2021, etc., it's passing every one of those tests, and it's accomplishing what we wanted it to do.